Hello and welcome to Honors Function. In this lecture, we're going to be looking at the symmetry of a function. If I'm talking about the symmetry, I'm of course talking about the geometry of the graph of a function, and we're going to try to spot what analytical property gives us some indication about the symmetry of the graph. Okay, so it's a relation between algebra and geometry. What algebra property of a function will tell us the symmetry of its graph. Okay, let's start. Alright, we will be focusing on two different symmetry. The first one is a symmetry with respect to the y-axis. So I'm sorry, my graph is not very good. I just did it quickly by hand. Let's assume it has a symmetry with respect to the y-axis. If you were to fold this graph along the y-axis, you would find both branches to coincide. Okay, so now that we have the symmetry, what will spot the symmetry algebraically? So let's give a name to the function. Let's call it f. I'm trying to find a property that will tell me that I do have a symmetry. So if I have a point right here, let's take a point right there. Let's take an x-coordinate a right here. What do I expect to find? I expect to find right on the other side and at the same distance, right? So I'm going to go to the same distance. Let's assume that's it. I expect to find another point on the graph right here. Okay. Now, if it's the same distance, then what is the coordinate of this point? This point should be negative a. So what happens at a and at the opposite of a? Well, the output right here. What's this point? This point is the opposite of a, and it's f of the opposite of a, right? Well, this point is a f of a. I'm on the graph. What happens to both outputs? They are equal to each other. Okay? So if the graph has a symmetry with respect to the y-axis, I'm expecting that the output at negative x will be the same as the output at x for any x in the domain. Okay? For any x in the domain of the function. This is what going to indicate that the graph has a symmetry with respect to the y-axis. Alright, this is for the first type of symmetry. Okay, second type of symmetry. Alright, well, the second type of symmetry is a symmetry through the origin. Okay, so what's going on here? So if I have a point right here, if I have a symmetry through the origin, by drawing a line going through the origin right here, if I go to the same distance, I expect to find a point on my graph right there. Okay, this is what I'm expecting, same distance on the other side. So what are the coordinates of this point right here? Well, let's suppose this is a f of a right here. Okay, now what do we have if we go to the same distance on the other side? Well, you have a couple of congruent triangles right here. Okay, but it's very easy to say that this is to spot that this is the opposite of a, and this right here would be the opposite of f of a, right? This would be the opposite of f of a. The distance have to be the same right here, okay, because of some congruent symmetry. The coordinate of this point are a f of a. The coordinate of this point, well, it's the opposite of a, and the output is f at the opposite of a. So if we do have the symmetry, we expect that f of negative a equals the opposite of f of a. Okay, this is what we expect. So when we have a symmetry through the origin, we want f of negative x to be equal to the opposite of f of x for any x in the domain of the function. Okay, again, that's the reason, because I want the symmetry through the origin. Therefore, I'm expecting the output at negative a to be the same as, or to be the opposite as the output at a. Okay, so we have therefore two relations, one for a graph that has a symmetry through the y-axis, and another one for a graph that has a symmetry through the origin. The function f, the function that has this algebraic relation is called an even function. Even function. Okay, the function that has this relation is called even, and so we know the graph of an even function will have the symmetry through the y-axis. The function has this kind of relation that exhibits this kind of relation is called an odd function, okay? The function that exhibits this relation is called an odd function, okay? And if I ask you to study the parity of the function, the word parity, check it out in the dictionary, it stands for odd or even. Or also, it doesn't have to be odd or even, right? It could be neither. All right, so if I ask you to study the parity, I'm talking about odd, even, or neither. Okay? All right, let's go over the first few examples. Okay, determine the parity of the function below. If the function is neither, is there one change you could make so that it would turn into an even or an odd function? Okay, to determine the parity of a function, you have to see what happens when in the function you throw the opposite of x, okay? So let's see here. The opposite of x is 2 times the opposite of x squared plus 1. Then once you throw the opposite of x, you're trying to simplify this. Well, that's easy, right? It's 2 times the opposite of x squared is exactly the same as x squared. I mean, it's a property. So it's 2x squared plus 1. Can I go further? No, I'm done. That's about all, right, I can do. Now let's see. Is this equal to f of x? Yep, this is equal to f of x. So f of negative x is equal to f of x. The function is even. I hope you understand. It's pretty simple, right? Okay, let's look at the second one right here. Okay, so let's do g of negative x. What is g of negative x? It is 2 times negative x squared plus negative x plus 1, right? Okay, so 2 times negative x squared, this is the same as 2x squared. Plus negative x, we normally write it as minus x plus 1, that's it. Can I simplify further? No, I'm done. All right, so now question. Is this equal to g of x? Well, let me see. 2x squared plus x plus 1, 2x squared minus x. No, it's not equal to g of x, right? This is a minus x right here, so that's not g of x. Is this equal to the opposite of g of x? Is this equal to the opposite of g of x? Well, what's the opposite of g of x? It would be negative 2x squared minus x minus 1, and this is not. So it's not equal to the opposite of g of x. Therefore, this function is neither. It's neither odd nor even. Is there one thing we could do to turn it into something? Yes, it's very easy. If you think of the first example, we can just get rid of this right here. We could get rid of this. If you get rid of the x right here, it's going to be turning into an even function. Why the x? Because you see, this x squared is going to swallow up the negative sign, right? If you put a negative sign inside the square, it doesn't see it. It doesn't care. But this one will not swallow it up. It's going to spit it outside, basically. All right, I'm sorry for the image right here. Okay, let me do number 3. Let me do number 3 right here. All right, number 3. H of negative x equals, so let's see, 2 times negative x cubed minus 2 times negative x. Okay, let's simplify this. Now, here we have a negative x cubed. Now, negative x cubed is the same as the opposite of x cubed. Now, I hope you understand there is a difference between these two things, right? The base right here is negative x. Negative x cubed means negative x times negative x times negative x, while here the base is x. And this means negative x times x times x. But they come out to be the same, okay? So we have, it's going to spit the negative sign outside right here, negative 2x cubed, and then these two will turn into a plus 2x. Okay. Is this g of x? Is this g of x? No, it's not g of x. Okay, so it's not g of x. Is this the opposite of g of x? Well, yes, and I could have spotted that before. I can take a negative sign out right here. Let me take it out. If you take a negative sign out, it's negative 2x cubed minus 2x, right? And this is just h of x. I'm sorry, it's h, it's not g. So it is the opposite of h of x. Therefore, my function is odd. My function is odd. And you see, one of the reasons, I mean, my function is odd because my powers are odd, and odd power will throw the negative sign outside, and therefore you can just take it out. You know, if you got a negative sign outside, you can take it out. Now, look, if I add a plus 1 right here, That's it. I'm blocking the oddness of the function. Oops. I just answered number 4. So please do number 4 and do number 5, and I'm going to do number 6, and I'm gonna let you do number 7. The function is m, so let's look at m of negative x. M of negative x is 2 times negative x times square root of negative x squared plus 1. So it is negative x, we put it outside, negative 2x times square root of x squared plus 1. And this is just, well, look, this is m right here. This is negative m of x, right? And so the function is odd. Okay, that's it. I hope you realize it's very, very simple. With habits, you can spot it right away. Right away, you can see which term is going to turn the function into an odd or even. And even sometimes, in cases like this, you will be able to say right away if it's odd or even because of property of ratios, okay? Let's look at the graph. Let's look at the graph of some odd or even function. Just looking at the graph, you can say if the function is odd or even. So I'm going to do the first 3. I'm going to let you do the last 3. So this is obviously odd, okay, because we have a symmetry through the origin. See, this point right here goes there. This point would go like right here. This point would go right here. This is how the symmetry through the origin works, right? You go on the other side, same distance, and you should find a point on the graph. Here we have an even function, and here we have an even. Okay? All right. That's it with this short video. Thank you for watching.